Okay, so they want us to graph this quadratic, and they want us to use the graph to find the roots. I just like to find the roots algebraically. So I'm going to find that and then use the graph to support that my roots are correct. So how do I find the roots algebraically? I factor the quadratic when it equals 0 because I want to find what x can equal when y is 0. And that's when you have your roots, when y is 0 here. So to factor this, we set up parentheses, we're going to need x times x to get the x squared. And then we define two numbers that multiply -8 and add to 2. Those two numbers are going to be +4 and -2. Multiply +4 and -2, you get -8, add them, you get +2, and you're done. So this equals 0, right? But that means that x plus 4 or x minus 2 or both of them are 0, because in order to get a 0 product, one or the other or both of the numbers have to be 0. So here, if we say x plus 4 equals 0, and we subtract 4 from both sides, x equals -4. So when x equals -4, y is 0. That's one of our roots right here. This is a root. And over here we have x minus 2 equals 0. We add 2 to both sides, and x equals 2. That means one of our other roots is 2 and 0. Those are our roots. So we plot these, we get -1, 2, 3, and 4. This is one of our roots. -4, 0. That's a root. And the other root is 2, 0. So now what's going to help you graph this is to find the axis of symmetry so you can find the vertex. The axis of symmetry is just halfway between. So you can kind of tell right now that halfway between it's got to be this line right here. Alright, it's halfway between your roots, and that's your axis of symmetry, x equals -1. But you can always calculate that quickly by taking -b and dividing it by 2a. So here b is 2, so -b is -2. Over 2a is 2 times 1. So it's -1. So that means x equals -1 is the line for the axis of symmetry. And that's a key value because the axis has to cross the vertex, right? So if the axis crosses the vertex, you can find your vertex by plugging in -1 into your quadratic. So here, when x equals -1, we have -1 squared plus -2, right? Because 2 times -1 is -2 minus 8. So it's 1 plus -2, that's -1, right? Minus 8 is -9. So that means our vertex is at -9. So we can plot that. 1, 2, 3, 4, right? 5, 6, 7, 8, 9. So right, missed it right there on the graph. So you would have enough graph paper, of course. Here I don't. So here, that means the vertex is -1, -9, right? And just double check. 1 minus 2 is -1 minus 8. Okay, it's -9. So now once you have this, you can set up a rough graph, because all you really need is to connect these points in a way that kind of makes sense, right? So you're going to show the curvature between the points here. Maybe do a better job than that here. Let me fix that. Oops. Oops, wrong button. Sorry. Alright. So the curvature you want to show here. And then extend your arrow. And then here, do the same thing. You want to be as accurate as possible. If you want to get the best kind of graph, you can plug in other x values between the vertex and the roots, right? So here, label this root. Maybe I'd plug in 3 and -5 outside the roots to get another point. Maybe I plug in points here as well. But the more points you plug in, the better. I think 3 is enough, but if you plug in 2 more, you'll definitely have a great graph. Okay. Which ordered pair is the solution set of the system of equations? Well, two ways to go about this are to set this up on a graphing calculator and find the intersection, or you can do it algebraically. I guess I'll do both. So here, when these two lines, when this line and this quadratic meet, they're equal. So we have fix this. So -x plus 1 at some point, or 2 points maybe, equals x squared plus 5x plus 6. So let's find when they're equal. If I add x to both sides and subtract 1 from both sides, what's going to happen? Well, what happens is I get 0 equals x squared plus 6x plus 5. And now, if I solve this algebraically, right, I can factor this out. So x, right, and then x over here to get x squared. You need factors of 5 to add up to get 6. So I'll pick 5 and 1. Okay. So they're saying this equals 0, so that means x plus 5 could equal 0. And also x plus 1 could equal 0. So we subtract 5 from both sides here, and x equals negative 5. And we subtract 1 from here, and x equals negative 1. This means that when the two formulas meet, x equals negative 5, and x is going to equal negative 1. So out of the choices they give us, so far, 3 and 4 we cancel out because it has a positive 5. But we have negative 5, so let's plug that in. We can plug into either formula because at this point, they're the same. So I'm going to plug it into the line that's just, easier to work with. So y equals negative x, so negative 5 plus 1, so y equals 5 plus 1, right? And y equals 6, so that point is negative 5, 6. That's choice 2. But let's look at that on the graphing calculator as well. So go to our y equals, clear this off, and we have negative x plus 1, and then we have x squared plus 5x plus 6. Oops, I'm entering all that into an exponent. Clear that off. Okay, again, x squared, press the right key this time, plus 5x plus 6. Okay, now when we graph these two, we'll see that they cross twice, right? And if you want to find when they cross, just hit second trace, and you want to find they intersect, so hit choice 5. So it's going to ask you to identify what the first and second curve is. Here the line is not a curve, but they're going to treat it as that. Press enter, then press up to toggle over to the second curve right there. So now you see it's flashing on the second curve. Enter again, and they want us to guess. There's one of our intersections, negative 1, 2. But we can do the same thing and find the other one as well. So again, hit second, calc, intersect. This time, we want to get over towards the other intersection to find when they meet. So scroll over to the left here. Maybe about there. Okay, so that's our first curve. Enter. Second curve. And toggle, sometimes it seems a little finicky, so toggle right and then down or whatever. And then here I'm on the second curve. Okay, great. Guess there it is, negative 5, 6. So the calculator can find the intersections as well by graphing and then hitting second trace. Okay, which ordered pair is a solution of this system? So we can solve this algebraically or on a graphing calculator. We'll do both. So if they're going to have a solution at some point, an ordered pair, it's just a point where they're equal. Well then, at some point, these two things are equal. So 3x minus 15, let's find when it equals x squared minus x minus 20. So to solve this, I would add 15 and subtract 3x from both sides. So minus 3x plus 15. This cancels out to 0, equals x squared minus 4x minus 5. So now when we factor this, we want to find factors of negative 5 that add up to negative 4. And I know that if I take negative 5 times positive 1, that multiplies to negative 5, but adds to negative 4, so I'm going to use those two numbers. And this equals 0. So automatically, then this means that x minus 5 is equal to 0, or x plus 1 equals 0. In both cases, solve for x. Add 5, x is 5, subtract 1, x is negative 1. So this just means that the x values when these two functions meet are 5 and negative 1. So we can cross out choice 3 and 4 from our list. Those don't have, choice 3 has 0. And we can cross out choice 1 because it has negative 5, but we need positive 5. So now, to find out what the actual point is, plug in the simplest value to the simplest equation, because here all things are equal. So let's do the line. 3 times 5 minus 15. So that's 15 minus 15, it's 0, so the point is 5, 0, right? That's one of our points. I don't see it listed. Try the other point. Try negative 1. 3 times negative 1 minus 15. So it's negative 3 minus 15, that's negative 18. So the point is negative 1, negative 18. And that point is here, choice 2. On the graphing calculator, go to y equals here, clear these functions out, enter in 3x minus 15, that's our line, press enter, clear off any functions that are there, hit x squared, press the right key to get out of the exponent, minus x minus 20. Okay, graph. Okay, so this is showing part of it. I'm going to zoom out so you can see the whole thing here. But here you want to choose the center around which you're actually zooming. Okay, enter. Alright, so we get a better picture of it here. And you can see that it crosses twice, but if you want to find exactly, hit second trace, hit 5 for intersect. Here you have to kind of toggle around to select once on the line, and then up or over, just to get on the curve there, press enter, and then it's asking for a guess, yes. And there's the intersection, -1, -18. If you want to find the second intersection, scroll over to this right area to find this intersection as well. Okay, so we want to solve graphically for the system of equations. In other words, they want us to graph both and find where they meet. So first of all, I'm going to graph the line. It's my easy starting point. Subtract 2x from both sides and you get y equals -2x plus 6. That's an mx plus b format. So now we know that 6 is the y-intercept. This is our b value. And -2 is the slope. So that's easy to plot, right? We have our graph right here. Here's 1, 2, 3, 4, 5, 6. Our y-intercept, our slope's -2, down 2 over 1, right? So we graph this, and then up. You want to be as precise as possible. You have a ruler for this. Make sure all the points line up. It's not a terrible job, but that'll do. Okay, so y equals, and label it, -2x plus 6. Now for the quadratic, I think we'll need the vertex and we'll need the two roots. So let's find the roots. X squared minus 6x plus 1 equals 0. I say equals 0 because the roots are when this thing equals 0. So set it equal to 0 and solve. Factor it out. Oh, we run into a little bit of a dilemma here because I didn't do this on purpose. So in order to factor this, there are no factors of 1 that multiply to get -6. So we can't use the factor strategy that we have here. So instead, I think what we'll do, first of all, is find the axis of symmetry. So -b over 2a, that'll help us start. So b is -6, so b is -6 over 2 times 1. A is 1 here. So we have 6 over 2, which is 3, right? So that means our axis of symmetry is x equals 3. It's this vertical line here at 1, 2, 3. And that's going to, I think, help us find the intersection. You can see that these lines are crossing already. So let's see where this goes. So x equals 3. So this line is special because it folds the parabola in half, but it has to cross the vertex. So we know the vertex has a point 3 and then something is on this line. We plug 3 into our equation, we can find the y value. So 3 squared minus 6 times 3 plus 1. So 9 minus 18, excuse me, minus 18 plus 1. 9 minus 18 is -9, plus 1 is 10. Right? So that means the point, the vertex, is at 3, 10, excuse me. No, it's not 10, sorry. What am I doing? 9 minus 18 is -9, plus 1 is -8. Right? So here, that means our vertex is at 3, -8. So let's scroll down and see if that helps us. So 1, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7, 8. Here's your vertex right here. Okay. So the graphing here is a little tricky because we can't use the roots, and we know where the vertex is, but the vertex doesn't meet the graph. Right? The vertex is down here. So at this point, I feel like with many of the tools that we have for graphing, we're a little bit stuck. We can use the graphing calculator to quickly solve it, but I want to make sure we can solve this algebraically as a backup. Let's see if we can do that. I think I have some room down here. So our two functions are y equals -2x plus 6. One does equal our quadratic, which is x squared minus 6x plus 1. X squared minus 6x plus 1. So I subtract 6 from both sides and add 2x to both sides to get everything all on one side. So here this cancels out to 0. We get x squared minus 4x minus 5. So now we've got something we can work with. 0 equals, factor this out, this is factorable. So negative 5. What factors of negative 5 add to negative 4? Well, positive 5 and negative 1. Excuse me, reverse that. Negative 5 times positive 1 is negative 5, and add them and get negative 4. This gives us the 2 times when these two equations meet, right? So here, when do they meet? So x minus 5 could equal 0. We're almost finished here. And add 5 to both sides, and x equals 5. So that meets there. So the points meet at 5 something. Plug 5 into your equations to find the value of the point. So our linear equation is negative 2 times 5 plus 6. That's negative 10 plus 6 is negative 4. Right? So that's one of our points. The other point is x plus 1 equals 0. Subtract 1 from both sides. X equals negative 1. Okay, so that means that our points, our lines meet at negative, our line and quadratic meet at negative 1 something. Plug negative 1 into your line to find where they meet, right? So negative 2 times negative 1, that's positive 2. Plus 6 is 8. So here, they meet at two values. 5, negative 4, so let's plot that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and negative 4, they're going to meet right here. So, curve that up, right? So quadratic, they're meeting there. And the other one is meeting at negative 1, 8. So it's way up here, right? Negative 1 and 8 here. So, sorry. There we go. Make it as symmetrical as possible here. Alright, so, okay, let's just recap, because this one was a little challenging, I think. So here are the intersection points. This is 1, 2, 3, 4, 5, negative 4. Yep. And negative 1, 8. Alright. So first of all, they want us to graph, right, to solve this. Here's the problem, though. They gave us a quadratic that will require the quadratic formula in order to find the roots of it, right? You see these roots don't meet at friendly numbers, and furthermore, those roots wouldn't even really help us find the intersection, only approximate it. So that's a problem in the design of the question, but we worked around it. Here we graphed the line first. That was the blue. mx plus b format helped us. Then we found the axis of symmetry for the parabola and the vertex. We used the axis of symmetry to find the vertex. That was the point 3, negative 8. But that didn't get us anywhere. So then we used algebra. We set the two equations equal to each other, factored it out, and that was the key. That gave us the 2 points at which these functions meet, and then we set up the graph to match that solution. And that might be something you encounter, right? The structure of this problem is particularly challenging, but we found a way around it.